Hey everybody, welcome back to yet another fun and exciting Algebra 2 class. Today we are going to be talking about complex numbers, okay? Complex numbers are basically imaginary numbers with regular numbers or real numbers. And so maybe you're thinking, well, what is an imaginary number? Well, we did talk about imaginary numbers a little bit in Algebra 1. But if you don't remember, an imaginary number is when you have a negative inside of the square root. Let's look down here at the screen and it says the square root of -1. Well, what is the square root of -1? Well, we know that the square root of 1 equals 1. 1 times 1 equals 1. So to square root it, square root of -1. But the problem is with -1, nothing gives us -1. So if we have -1 times -1, that equals +1. There is no two numbers that are the same that we can multiply together to give us -1. It doesn't exist. It's not real. So what mathematicians have done is they've said, if you ever get this, because it's possible. Remember when we were doing the discriminant in the last lesson, when we were getting things underneath the square root sign in the quadratic formula? Well, what happens if, and it happens, if we get a negative number underneath of that? So that means we just can't solve it. There's no solution. We're done. Well, no, not necessarily. Here's what it means, that we have no real solutions, and that our solutions are going to be imaginary, okay? But mathematicians have designed a way for us to still get an answer, even though it's an imaginary answer. The way that we do that is what's called extracting the imaginary, or extracting the negative. So here's what this equals. This equals, and again, we're going to pull this negative outside. And so by pulling the negative outside, we turn that to an I. And it's a weird looking I. And I wrote it like that on purpose because it's italicized I. Maybe you've wondered why you've never seen the letter I used in equations. Why do we use X and Y and Z and A and B and C? Why do we use those letters all the time? Because those letters don't have any other designations in math. We don't use it. We don't say, okay, 6I equals 10. We don't do that, okay? And maybe you wonder, why don't I use I? Well, because I is actually used for imaginary. It's like we also don't use the letter F. We don't use the letter E. And it's because they have other uses, other designations in mathematics. So here's really kind of the first letter that we're coming to that has its own designation, and that is the letter I. And typically you're not just going to want to write this like a regular I. Kind of write it with the little, thing like this, and so that you can see that it's a different type of an I. It's an italicized I. And that will help to set it apart so that you understand that it's not a variable. Okay? So, here's what we did. We took out the negative sign, and then what we end up with here is basically this. Square root of 1. Imaginary square root of 1. Well, we can solve the square root of 1, so that would give us an imaginary 1. Or anything times 1 is just imaginary. So, the square root of -1 is imaginary. Imaginary 1. Okay, or just imaginary. What would I do if I had, for example, let me back this up a little bit here, and let's say that we had the square root of -5. Same thing, same process. We would pull out the I, we'd pull out the negative, and we'd get I square root of 5. Now here's the problem. We can't solve the square root of 5, so this would be our answer. Okay? What happens if we have one that we can solve? So we have imaginary square root of -25. Well, we'd pull out the imaginary, so we'd have imaginary. That's the negative sign we've pulled out. And then we would have 25. Well, we know the square root of 25 is 5, so we'd have I 5. Now, technically, you don't want to write it I5. I'll accept that. If you write it I5, it's fine. But 5I would be a better way to write that. Okay, 5I, 5 imaginary. If you still had the, inside like we did before, we had imaginary square root of 5, that's the best way to write that one. But when it comes out, usually you're going to write the number before the variable. Technically, this I is not a variable. It's the imaginary, but we'd still write it first. And again, if you write it I5, fine. If you write it 5I, fine. It's the same to me. Because it's multiplication, and multiplication is commutative. We can switch them, and it doesn't change anything. So no problem there. All right, let's continue on. So that's an imaginary number. Well, what about complex numbers? That's the name of the chapter, complex numbers. So what a complex number is it's a real number, 5, 7, 10, 3/4, fractions, 0.65, anything that's real, plus an imaginary number. So what's an imaginary number? It's a number that we just did with the 5I. Okay, and so what we would do here with a complex number is we would end up with, in our solution, we could have something that, is a real number plus an imaginary number. And they call them complex. Well, we have a standard form of complex numbers. And the way that we do that, the way we write this standard, a standard means everybody does it this way. So we would write our number first, then our plus or minus sign, and then our imaginary number. So 3 plus 2i would be the proper way to write that. Okay, 3 plus 2i. Now this section, I like this section. This section makes me happy right here as a math teacher. Okay, so on page 100, the chart itself is on page 100. Page 99, it introduces it. Page 99, and then page 100 is the actual chart here that we're looking at, the powers of I. Well, what we do is we would say that I to the first power, okay, which would be, in essence, which is this, okay, that's I to the first power, is imaginary. I to the second power, which would be this, square root of -1 squared. So this is imaginary. This in here is imaginary. So that's imaginary squared. And imaginary squared equals -1. Okay, so I'm not going to go through all of this to tell you exactly how all this works mathematically. And there's some theory behind this. This is not all like cut and dry in fact, but the idea here is that when you square I, you get -1. You're just going to have to kind of take that at face value. You're going to have to say, okay, Mr. Steve is teaching me that. I believe him. It's what the book says. I believe it. And then leave it at that. If you want to look into it a little bit more, again, there's some theory behind it. There's some kind of like the whys that mathematicians would say that it equals that. But this is just accepted in mathematics. And this is kind of like, this is just what it is. But again, if you want to go deeper into it later, you'll have more classes that will take you deeper into it if you stay in mathematics. If not, just accept it at face value right there. So then the next one would be I3, or the cube of imaginary, is negative imaginary. So you have imaginary, that's imaginary to the first power. -1, that's imaginary to the second power. And then you have negative imaginary, that's imaginary to the third power. Then you would have imaginary to the fourth power, and that is a 1. That is a 1. If you kind of think of it this way, it's squaring I squared. When you square -1, well, -1 times -1 gives you 1. So there's some kind of some logic there. But anyways, these are key right here. These powers of I, you need to know these. Now here's the neat thing about this. The cycle, it just keeps continuing like around in a circle. So for example, if I give you I to the 5th power, okay, and so here's what that would be. And this is the easiest way that I tell students to do this. If you will just take this right here, and if you will divide it by 4, okay, and so that's going to give you what? So 5 divided by 4 gives me 1, 4, and whatever your remainder is, okay, so remainder 1. Whatever my remainder is, if I go to the chart and I use that, that's kind of my leftover exponent, okay? My remainder is my leftover exponent. Whatever that remainder is, that's what this equals. So I5 equals imaginary. I5 equals imaginary. Let's do another one. So if I5 equals imaginary, what would, we can throw any number that we want to in there. What does I12 equal? Okay, I12. Well, use the same thing that we just used. 12 divided by 4. Find your remainder. Whatever your remainder is, that's what it's going to be. 4 goes into 12 3 times, and it gives you a 0 remainder. Well, what's a 0 remainder? Well, that one's this one right here, because look, 4 divided by 4 gives you a 0 remainder. If you get a 0 remainder, it's this one right here. It's 1. So I12 would equal 1. Let's do another one. Let's, I don't know. Let's try some other random ones. 27. I don't know. 27 divided by 4. 4 goes into 27, what is that, 6 times? 24 with a 3. Our remainder is 3. And so we would look over here, and there we go. Remainder 3, that equals negative I. So whatever your exponent is, divide it by 4. So this one, you might want to put this one is remainder of 0. The 4 is the remainder 0 ones. So if you get a remainder of 1, it's I. If you get a remainder of 2, it's negative 1. If you get a remainder of 3, negative I. If you get a remainder of 0, 1 is the answer. Okay? All right, so let's do one of those real quick. Almost done here with this lesson. I'm going to do this lesson in 2 parts, by the way, so some of you are getting nervous looking at how much longer there is in the lesson. All right, so whenever you get a remainder of 0, remember when I said your leftover remainder is 0? Anything 7 with a remainder 0 always equals 1. So this one's easy to remember that that's going to equal 1. So you always just take your leftover remainder after you divide by 4, and hopefully you'll get that. Let's do one more thing. No, I'm gonna save that for next lesson. So I'm just gonna end it right there. It's 15 minutes anyways. That's good. That's all you need. You don't need any more than that, right? All right. So we'll do the rest of it. That's all the base that you need for this lesson. And that next lesson will come in and we're gonna do some arithmetic, some adding, subtracting, multiplying, and dividing. Okay. All right. We'll see you later. Bye bye.